we go. Let's record. So, this unit's all about forces. Forces are what make things, well, sometimes, make things move. Forces impact you all the time. Forces do all sorts of wild and wonderful things. There's on the book that's right here. When I say the word force, or you think about this concept of forces, what do you think of? What comes to your mind when I say that? Sorry, Brad? Movement. What do you mean? On a really vague level. Like a force causes something to move?
Yeah.
Or to... Okay. That's what you think of? Okay. So let's take a look at Brad's definition. Something that makes something move. That's pretty vague. Do forces always do this? What other things do you guys think of when you think of a force? Or that concept of forces? Sorry, Dwayne? What'd you say? Henry, what did Dwayne say? Oh, Dwayne definitely said something. It was profound, I'm sure. Okay, well then let's unpack Brad's definition here a little bit. Do forces always make something move?
No.
Okay, then what? Okay, so if they don't, then let's change your definition.
They make something stop.
Sure. Let's add something to Brad's definition. Or stop. Energy's next chapter. You're basically defining momentum. That's the next thing we're going to talk about. Next week, maybe? We'll see how fast we get through it. What do you mean by that, Emma? The transfer of movement.
I don't know. I just like, you know, like if, I don't know, what's that thing where it has like the green ball and push on it?
Yeah, that's what's called. So Newton's cradle, where you take the thing.
Yeah.
So what part of that is there why are you thinking about that?
Like a force is like if he says something that makes something move or stop, like the energy sort of transfer that before they move.
Okay, so you raise the first ball, it comes in, it hits the next ball, hits the next ball, hits the next ball, kicks the thing up. Okay, yeah. Yeah, there's definitely forces involved there. Are there forces acting on you right now? So Brad's definition was something that makes something move or stop. You guys aren't moving or stopping, but are there forces acting on you right now as you sit in class? Ezra says yes. Okay, Ezra, what forces are acting on? Gravity, okay? So gravity is acting downwards on you, pulling you towards the center of the earth. Is it making you move right now? So then we need to augment Brad's definition. It's something that makes something move or stop. Are you falling towards the center of the earth, even though gravity's acting on you? Yes. No, you're not. Why aren't you falling through the floor? Sorry, because there's a floor? What's the floor doing to you? Okay. It's there preventing you from falling. So if gravity's acting downwards on you, the floor has to be acting upwards on you. And if you're not moving, what can you tell me about those two? They have to be canceling out. So every moment of every day, there's always something, there are things that are acting on you that are making you move, stopping you from moving, or keeping you where you are. Keeping something, wow, this pen sucks. There we go. Something where it is. that's a super vague definition. But that's kind of what forces are. And we're going to look at specific kinds of forces and name them depending on how they do this. Because they all do it differently. Emma said the forces of the floor acting up on you and gravity pulling down on you cancel each other out. So then what kind of forces would there have to be that cause you to move? We'll use Emma as an example. Emma's the one that gave us this insight. Let's say, okay, Emma, you are sitting in the chair, gravity's acting downwards on you. What happens if I come up behind you? Take away your chair. Here, sit, have a seat. Just have a seat. I'm gonna pull it away, it's true. No, I'm not gonna pull it away. You know what I was gonna. Okay, so Emma's trying to sit. If I pull away the chair, what's the person do? Falls to the ground. If you fall to the ground, that means the chair is not there to hold you up, which means there's nothing preventing you from falling all the way down due to gravity. Or if I'm watching it this morning during my spare, I was watching a show. The floor broke. Person falls through the floor. What are they doing as soon as the forces are no longer canceling each other out? Yes, falling under gravity, which means they starts with an A. Accelerating. So an idea here is that forces are something that makes something move, stop, or keeping something where it is. As soon as you take that and unbalance it, if there is an unbalanced force, unbalanced F, I'm going to abbreviate force with the letter F now, causes an acceleration. The easy example, A-C-C-E-L, acceleration. Oh, there's an R in there. Acceler. Dang it. E-R. Acceler. For the love. Let's start again. This is embarrassing on a Monday morning. A-C-C. Acceleration. There we go. There might even be supposed to be two L's in there. An unbalanced force causes an acceleration. The guy who put all this together, his name is? Sorry, louder? His name's at the top of the page. Newton. So he's the guy that gets the units. The units of force are newtons. He's the guy responsible for the foundational ideas of force. He did it with gravity first, and then he threw down his laws of motion, all relating to forces acting on other things. And then he actually invented calculus first, and then he did this, and then he turned 26. The dude was brilliant. And so he's the guy that gets credit for this. Units of force are newtons. We give it the capital letter N. And then when we actually go through and look at this idea, unbalanced force causes an acceleration, we're going to look at that mathematically. There's going to be another set of units that I give you. So that's Brad's definition is pretty good. Emma gave us the idea that an unbalanced force causes an acceleration. Those are the units. There are 4 fundamental forces that make up all the forces in the universe. Everything can be distilled down to 4 fundamental forces. Does anyone have any guesses as to what those are? Gravity is the first one. Gravity, there's a few ways to explain what gravity is. In this unit, we are going to explain gravity as the force between masses. Anything that has mass creates the effect that we call gravity. You create the effect that we call gravity. You just do it on a much smaller level than more massive things like planets and suns, for example. But if you have mass, you create the effect that we call gravity. As far as Newton understood it, it's a force. I'm going to show you a video in a couple days that's going to explain to you that gravity is not actually a force, but we'll get there. That's the first one. There's 3 more. Gravity is the first one that you become familiar with as a child. Things fall. The second one that you become familiar with, generally you become familiar with when you play in front of the fridge as a child. What do you play with on the fridge? Magnets. Magnets are a fundamental force. We call that force electromagnetism, or the electromagnetic force. And we call it electromagnetic because electric force and magnetic force are actually the same thing. Depending on which one you're experiencing, it depends on how you look at it. If you can shift your perspective, you can alternate back and forth between the ideas of magnetism and the ideas of electrostatics. They are one force. So electromagnetic is the force between what? You learn about it in grade 9. Certain kinds of charges are attracted to each other. Other kinds of charges are repelled from each other. Positive and negative are? Sorry? Are attracted to each other. If you have 2 positives or 2 negatives, what do? They repel each other. Magnets are similar. If you have a North Pole magnet and a South Pole magnet, they come together. If you have 2 of the same pole magnet, they push against each other. So electromagnetic force is the force between charged objects. Those are the two fundamental forces that you're likely the most familiar with. I would not expect anyone else to be familiar with the next 2 unless you've done some advanced reading in physics. The next 2 are the strong force. I know, not a great name. And the fourth one is the weak force. Not overly creative names. And I'll define what these are for you here in a sec too. The strong force, actually I'll do the weak force first. The weak force holds nuclei together. So the force that exists that holds protons and neutrons together in the nucleus of an atom, we call that the weak force. We don't really have a better explanation for it. It's not electromagnetic. It's its own thing. And then perhaps you've never thought about it, depending on what your Science 10 teacher taught you. Protons and neutrons can actually be broken down further into smaller particles. Smaller particles called quarks, and quarks can be broken down into other things. It gets weird. So the strong force, so the weak force holds nuclei together. The strong force holds atomic particles together. So a proton is made up of 3 quarks. You don't need to know anything more about it than that. There's 3 quarks. They come together. The force that holds them together we call the strong force. And then once you have the strong force holding those guys together, you need another force to hold this proton to this proton and that neutron together. That's the weak force. So these are the 4 fundamental forces. But in your life, as you go about, being who you are and experiencing the world, you experience a whole bunch of other forces. We've already talked about gravity. We're going to talk about gravity in lots of detail this chapter. Gravity, we are going to call F, big F, with a little g next to it. This is, again, same definition I gave you before, force that acts between masses. And then the reason you don't fall through the floor is because something has to be pushing up against you. That the something that's holding you up changes all the time. Right now, it's only sort of the floor because you're not sitting on the floor, you're sitting on a chair. So the chair is holding you up. The floor is holding up the chair, but what's holding up the floor? Like there's layers to all these forces, right? And so what we do is we give that holding up force, all of them, whether it's the chair or the floor or the girdering inside the floor or whatever it is, we give that a name. When you are in contact with a surface, the force that exists between you and that surface we call the normal force. And we call it big F subscript capital N. And this force acts whenever you are, what is going on? In contact with the surface. This word normal has, excuse me, a meaning you're probably familiar with. It also has a mathematical meaning that you might not be as familiar with. Does anyone know the mathematical meaning for this word normal? My European students. Okay. The word normal in math means 90 degrees. So this is a force that acts whenever you are in contact with the surface, and it acts 90 degrees to the surface. Or another word for that is perpendicular. Whatever surface you're on, this force acts perpendicularly to it. What other forces are you familiar with? Things that exist that impact your day-to-day life. Sorry, Colton? Okay. Don't say it. We don't want to say it. Okay, so you walk down the hallway. What is causing you to move forward? How does walking work? This is why this unit gets complicated. How do you walk? By pushing off of one foot. Okay, let's talk about pushing off. Okay, so I'm not Michael Jackson, so I'm not going to do it backwards. So I'm pushing off like so my back foot, I'm pushing forward. Switch feet. How am I able to do this? How come my foot doesn't go back? When I push back, how come the foot doesn't go back? Traction or friction. If I was doing this on ice, I would have to do it much more carefully because the ice has less friction. If the surface was totally frictionless, what would I be doing? What are they walking towards, Jack? No, I would be doing this. I wouldn't be going anywhere. Friction is the reason you move forward. Just kind of counterintuitive. Normally we think about friction holding you back or slowing you down. If friction doesn't exist, you don't walk. So friction is the force that's pushing you forward because you're trying to push back against the ground. So let's talk about friction. Friction is given capital F, lowercase f, force of friction. What causes friction to be a thing? If I wanted to reduce friction, what would I do? Make something smoother. So what you're suggesting is if friction is present, that means there are rough surfaces acting on each other. Okay? Can you do what? That's electromagnetic. You'll talk about that in Physics 12. So friction. Friction is caused by interlocking, and I'm going to put the word rough in quotes, surfaces. Because you might feel like a surface is pretty smooth, but I was thinking about if you can walk on it, clearly there has to be friction there. If you could move yourself forward, there is interlocking roughness to that surface. If friction doesn't exist, you wouldn't go anywhere on it. Alternatively, you could move anything on it relatively easily. For example, there's an aircraft. I like aircraft. I've always been interested in aircraft. There's an aircraft I'm particularly fond of called the SR-71 Blackbird. Hands up if you've ever heard of the SR-71 Blackbird. A few of you gentlemen in the back corner. Okay. So for those of you who have not heard of the Blackbird, it's retired. It was a Mach 3 United States Air Force spy plane. They couldn't shoot it down, not because they couldn't see it, but because they couldn't catch it. It went really, really fast. It was built so that, and when you fly really, really fast, there is friction between you and the air, and so metals heat up when this friction exists. And so to actually have the plane stay intact, they built it so that when it was stationary on the ground, it was loose. And when it was flying at Mach 3, it would heat up and then fit together properly. It didn't fit together properly on the ground. And so when you fueled it to take off, it was sitting there leaking because it didn't fit together properly until it was going at thousands of kilometers per hour. And then it would fit together properly. The fuel they used in that plane had the ability to reduce the friction between the aircraft tires and the ground to effectively zero. So when there was fuel on the ground underneath the wheels of the plane, you could grab the plane by the nose and any one of you could slide the plane around. Because yes, the plane was really, really heavy. It's a massive jet. But when that fuel got between if the fuel got between the concrete on the ground and the tires themselves, it reduced the friction to effectively zero. So that's the other way you can reduce friction, not necessarily by smoothing a surface, but by lubricating a surface. Okay, gravity, normal force, friction. I gave you another one just now. When you move through the air, you heat up. Caused by? Air resistance. Thank you, Dwayne. We don't call it air resistance, though. What do we call it? Starts with a D. 4 letters. Drag. So there's a drag force. We will call it F. It's drag. We're going to call it F air. This is force of air molecules. Hitting an object. And there's all sorts of ways to play with drag. I've got 4 more, but there are more than 4, but I got 4 more. What are some other forces you experience? What is this? Sorry? An elastic band. Are you afraid of the elastic band? Right now, it's just sitting here. It's nice and small and gentle. Are you afraid of the elastic band in this state? Are you afraid of the elastic band now? A little more than you were before. Why? Well, that's a different one. We're going to talk about tension in a sec. I've given it potential energy. I've given it potential energy because I'm holding back. As soon as I let go, what's this thing going to do? Well, the back is going to go to meet the front, and it's going to pull the thing forward. So there is a force there. It's not the me pulling back force. It's the idea that this rubber band doesn't want to be the way I stretched it. I let go and it reforms its shape. The idea that shapes will do this, we call the elastic force. We will call it F big E, and it's the idea that stretched objects want to restore themselves, or I'll say want to restore their shape. And everything has a different level of elasticity. So a rubber band is a pretty good example of something that wants to restore its shape when you stretch it. Your skin has elasticity. If it didn't have elasticity, well, a whole bunch of horrible things would happen to you when you tried to build muscle or you put on fat. If your skin didn't stretch and you're adding muscle underneath, your muscles would eventually tear through your skin. That would be problematic. If a lady's skin didn't stretch when she was pregnant, that would be disgusting and a whole host of awful things would happen. And the idea that your skin goes back, it restores itself after you've lost weight or after you've delivered the child. Your skin has elasticity associated with it. You said tension, Emma. Tension's another one. We're going to call it big F, big T. What's tension? And I don't mean like emotional tension. Where do you talk about tension? Where have you heard of tension? Why did you say tension, Emma? Well, in what context have you heard that word used? It just came to your mind and you're like, tension. Okay. Colden? What kinds of objects do we typically associate tension with? Springs are this one. It's like springs, but not springs. Tension we typically associate with not springy things. So what is like a spring but not a spring? We use them in similar contexts to hold two things together. Not a screw. This is a force associated with ropes, chains, etc. when pulling. Yes, ropes have some elastic quality to them, but not nearly as much as a spring would or an elastic band does. But ropes, chains, can be used to pull things. The force that we talk about existing within them is tension. There's another one. How many of you enjoy swimming? None of you enjoy swimming. Shame. When you get in the water, do you immediately sink? Density is not a force, it's related to the force. What causes you to not sink? Your buoyancy. We'll call it FB. It is related to your density. Causes you to float. So you float in water because you are less dense than it. You float better in salt water because salt water is less dense than fresh water. Believe it or not, you would actually float in liquid concrete because you are less dense than concrete. And then there's one more that we're going to tack on here at the bottom. We're going to call this the applied force. We're going to call it FA, and this is a catch-all force. If we don't have a general specific cause to the force, or if the cause is always changing, could be you, could be me. I'm not going to call this the force of me. I'm not going to call it the force of you. We're just going to say someone is pulling the thing. We'll call it an applied force. That's where we're going to end today. Tomorrow we'll look at free body diagrams, how we label these forces. When the bell goes, you may also go. Have yourself a super duper day. Welcome to Dynamics and Momentum.